Did you know that Brazil was once home to a giant, astonishing dinosaur? Meet Oxalaia, a spinosaurid from the Late Cretaceous period that roamed what is now Brazilian territory. Named after the African deity Oxalá, Oxalaia quilombensis is part of an ancient lineage of dinosaurs, yet with unique characteristics that distinguish it from the famous Spinosaurus. Oxalaia is a genus of large spinosaurid theropod dinosaurs that lived in Brazil during the Cenomanian stage of the Late Cretaceous. The type and only species is Oxalaia quilombensis. This dinosaur superficially resembles one of its close relatives, Spinosaurus, but has enough physical differences in its morphology to be classified as its own genus. All known fossils of Oxalaia were recovered in 2004 at the Laje do Coringa locality, part of the Alcântara Formation in the São Luís Basin, which is part of the Itapecuru Group. In addition to these bone fragments, numerous occurrences of spinosaurid teeth had already been reported at the site. The genus was named by Alexander Wilhelm Armin Kellner, Sergio AK Azevedo, Elaine B Machado, Luciana B Carvalho, and Deise DR Henriques in 2011, and the type species is Oxalaia quilombensis. The specific name quilombensis refers to the Quilombola settlements, such as those on Cajual Island, established by escaped slaves. Although Oxalaia is known only from two partial skull bones, Kellner and his colleagues found that its teeth and skull possessed some distinctive features not seen in other spinosaurids or theropods, including two replacement teeth in each socket and a highly sculptured secondary palate. Oxalaia's habitat was tropical, densely forested, and surrounded by an arid landscape. This environment hosted a wide variety of life forms also present in North Africa during the mid-Cretaceous due to the connection of South America and Africa as parts of the supercontinent Gondwana. As a spinosaurid, the characteristics of Oxalaia's skull and teeth indicate a partially piscivorous fish-eating lifestyle, similar to modern crocodilians. Fossil evidence suggests that spinosaurids also hunted other animals, such as small dinosaurs and pterosaurs. The discovery of Oxalaia highlights the rich prehistoric diversity of Brazil and offers significant insights into the evolution and adaptation of spinosaurids. Its unique features and the environment it inhabited provide a fascinating glimpse into a world long gone. Oxalaia is one of the three spinosaurid dinosaurs discovered in Brazil, the other two being Irritator and its possible synonym Angaturama, both also initially known from partial skulls. They were found in the Romualdo Formation of the Santana Group, part of the Araripe Basin. Microfossils date this formation to the Albian, about 9 to 6 million years before Oxalaia. The fossil record of spinosaurids is sparse compared to other theropod groups. Few body fossils are known, and most genera have been identified from isolated elements such as vertebrae or teeth. The holotype specimen of Oxalaia quilombensis, designated MN 6117 Phi, was found in situ, in its original place of deposition, with part of the left side embedded in the rock matrix. It consists of the fused premaxilli, frontmost snout bones, of a large individual. An isolated incomplete fragment of the left maxilla, main upper jawbone, MN 6119 Phi, was attributed to Oxalaia because it exhibited the same general traits found in spinosaurids. The maxilla was discovered on the rock surface, possibly moved from its original location after erosion. Both bone fragments were found on Cajual Island, Maranhão, in the northeastern region of Brazil, and were housed in the National Museum of Rio de Janeiro. In 2018, a fire destroyed the palace housing the museum, possibly destroying the Oxalaia specimens along with many other fossils found in Brazil. Besides the partial skull bones, several spinosaurid teeth had been previously reported from the Laje do Coringa site. Two partial caudal, tail vertebrae from the formation were attributed to the spinosaurid species Sigilmassosaurus brevicollis. American paleontologist Mickey Mortimer informally observed that these vertebrae might belong to Oxalaia. The discoveries of Oxalaia and the late Cretaceous reptiles Pepasuchus and Brasiliguana were announced at a presentation by the Brazilian Academy of Sciences in March 2011. Machado described Oxalaia as the dominant reptile of what is now Cajual Island. She stated that there is interest in spinosaurids in Brazil and abroad due to their appearance in the Jurassic Park franchise. and their distinction among other carnivorous dinosaurs. The species description of Oxalaia was written by Brazilian paleontologists Alexander Kellner, Elaine Machado, Sergio Azevedo, Deise DR Henriques, and Luciana Carvalho. This paper, among many others, was compiled into a volume of 20 works on prehistoric biodiversity published by the Academy in March 2011. The type species Oxalaia quilombensis is the 8th officially named theropod species from Brazil. The generic name Oxalaia is derived from the name of the African deity Oxalá, introduced to Brazil during the period of slavery. The specific name quilombensis refers to quilombola settlements, such as those on Cajual Island, founded by escaped slaves. The specimen UFMA 1.10, 240, a distal caudal vertebra discovered in the Alcântara Formation of Brazil, was attributed to Sigil Massosaurus in 2002. The premaxillae of the holotype measure approximately 201 millimeters, 7.9 inches, in length, with a preserved width of 115 millimeters, 4.5 inches. The original maximum width estimated at 126 millimeters, 5 inches, and a height of 103 millimeters, 4.1 inches. Based on skeletal material of related spinosaurids, Oxalaia's skull would have been about 1.35 meters, 4.4 feet long. This is smaller than the skull of Spinosaurus, which was estimated at 1.75 meters, 5 feet and 9 inches, long by Italian paleontologist Cristiano Dal Sasso and his colleagues in 2005. Kellner and his team compared Dal Sasso's specimen, MSNMV 4047, to the original snout of Oxalaia in 2011. From this, they estimated Oxalaia to be 11.9 to 14.5 meters, 39 to 46 feet, in length and 5.5 to 7 metric tons, 5.5 to 7.7 short tons, 4.9 to 6.9 long tons, in weight, making it the largest known theropod from Brazil, the second largest being Pycnonomosaurus, which was estimated at 8.9 meters, 29 feet, by a study. The tip of the rostrum snout is broadened, and the posterior end is constricted, forming the terminal rosette that distinguishes spinosaurids. This shape would have interlocked with the also expanded front of the dentary, lower jawbone. The rostrum of Oxalaia features large and deep foramina, openings, that are possibly nutrient channels for blood vessels and nerves. It is also more rounded in lateral view than that of Spinosaurus, whose upper jaw ends in a more sharply descending angle, as shown by specimens MSNM-Phi 4047 and MNHN-SAM 124. The maxillae show a pair of elongated thin processes that extend forward along the midline of the palate. They are enclosed between the premaxillae and border an elaborate triangular-shaped fossa at their front end. Similar processes are present in Suchomimus, Cristatosaurus, and MNHN-SAM 124, though not as exposed. These structures make up the animal's secondary palate. The undersides of the premaxillae are highly ornamented in Oxalaia, in contrast to the smoother condition found in other spinosaurids. The premaxillae have 7 alveoli, tooth sockets, on each side, the same number found in Anguittarama, Cristatosaurus, Suchomimus, and MNHN-SAM 124, referred to as Spinosaurus. MSNM-5 4047, another Spinosaurus upper jaw specimen, had only 6. It cannot be confirmed if this lower tooth count is due to ontogeny. A larger sample size is needed for that. A large diastema, gap in the tooth row, separates the third alveolus from the fourth. This is observed in all other spinosaurids, being smaller in Suchomimus. Another diastema of nearly equal length is found between the 5th and 6th alveolus. This diastema is seen in MNHN-SAM 124 and is much longer in MSNM-Phi 4047, but absent in Suchomimus and Cristatosaurus. The maxilla fragment attributed to Oxalaia, MN 6119-5, has 2 alveoli and a third broken one that includes a partial tooth. Like the premaxilla, it had preserved nutrient channels. It also shows a shallow tooth in the middle, suggesting it was located near the external nostrils, bony nostrils. Small fragments within some of the remaining alveoli show that, unlike its lower Cretaceous relatives Suchomimus and Cristatosaurus, Oxalaia had no serrations on its teeth. Besides the single functional tooth in each alveolus, there were 2 replacement teeth, which, according to Kellner, are a common feature in sharks or some reptiles but not in theropods. A cross-section of the teeth showed the typical oval shape exhibited by spinosaurids, rather than the lateral compression of other theropod teeth. The spinosaurid teeth found at Laje do Coringa were classified into 2 primary morphotypes by Brazilian paleontologist Manuel Medeiros in 2006. Both exhibit typical spinosaurian dentition, though morphotype 2 has smoother dental enamel than the first. The teeth of Oxalaia exhibit morphology closer to morphotype 1, while the second grouping of teeth represents worn teeth of morphotype 1 or an undescribed spinosaurine from the Alcântara Formation. Oxalaia's features are very similar to those of specimens MSN MVI 4047 and MNHN SAM 124, both attributed to Spinosaurus aegyptiacus. Kellner and his colleagues distinguished Oxalaia from this and other spinosaurids by its autapomorphic cranial dental characteristics, such as the sculpted palatal part of the premaxillae and the presence of 2 replacement teeth in each position. More fragmentary spinosaurids, such as Siamosaurus and Cynopliosaurus fusuiensis, are known only from teeth, making it challenging to distinguish them from other taxa. The habit of naming theropods based on isolated teeth or tooth fragments has resulted in many invalid genera and synonyms. This has also occurred with spinosaurids and is exacerbated by the common lack of overlapping skeletal remains, which are necessary for valid taxon distinction. In 2017, a phylogenetic analysis conducted by Brazilian paleontologists Marcos Sales and Cesar Schultz concluded that Oxalaia was more closely related to African spinosaurs than to Brazilian spinosaurs like Angaturama, as indicated by a broader snout and the absence of a dorsal sagittal crest on the premaxillae. The Brazilian genera Oxalaia and Angaturama were found to be the closest relatives of Spinosaurus, with Oxalaia forming its sister taxon. Although fragmentary, the Brazilian material indicates that spinosaurs were more diverse than previously recognized. Spinosaurus differs from Oxalaia by its significantly more spaced dental alveoli, the presence of a slight constriction between the 3rd and 4th alveoli, and the more pronounced slope of its snout. Currently, Oxalaia is attributed to the subfamily Spinosaurinae due to the morphology of its upper jaw and the absence of fine serrations on its teeth, which characterize baryonychines. Below is a cladogram by Sales and Schultz, in which Oxalaia is grouped in Spinosaurinae as a closer relative of Spinosaurus than Angaturama. In 2020, a paper by Robert Smith and colleagues evaluating spinosaurs from the Chem Group did not find the autapomorphies of Oxalaia quilombensis sufficient to justify a separate taxon, but instead considered them a result of individual variation. The authors therefore regarded the species as a junior synonym of Spinosaurus aegyptiacus. If supported by future studies, this would imply that Spinosaurus aegyptiacus had a broader distribution and support a scenario of faunal exchange between South America and Africa during the Cenomanian, when there was little water separation between South America and Africa, allowing Spinosaurus aegyptiacus to cross the short maritime distance to South America. The upper Cretaceous deposits of the Alcântara Formation have been interpreted as a humid environment of tropical forests dominated by conifers, ferns, and horsetails. These forests were surrounded by an arid to semi-arid landscape, subject to brief periods of intense rainfall followed by long periods of drought. A wide variety and abundance of animal taxa have been discovered in the formation, including dinosaurs, pterosaurs, snakes, mollusks, crocodilians, notasuchians, and fish. Among the aquatic taxa known from the deposits are the large Coelacanth Mawsonia gigas, the ray Miliobatis spando of uncertain species, 2 sclerorhynchid sawfish, and various bony fish, ray-finned fish, and lungfish species. Fossil remains of dinosaurs suggest the presence of diplodocoids like Itapuasaurus cajapioensis, basal titanosaurs, a giant Carcharodontosaurid espiento, a noasaurid closely related to Masiacosaurus, and a dromaeosaurid. Additionally, characteristic teeth and a vertebral centrum have been attributed to Spinosaurus spi. Most of the flora and fauna discovered in the Alcântara Formation were also present in North Africa, in the Kem beds of Morocco during the Cenomanian, with some exceptions, such as Oxalaia quilombensis, Atlanticopristis equatorialis, Equinoxiotis alcantariensis, and Coringa anisodontis. According to Medeiros and colleagues, the Laje do Coringa assemblage may also be connected to the contemporaneous Bahariya Formation in Egypt, which contains a distinctive combination of key taxa, including Spinosaurus aegyptiacus, Carcharodontosaurus saharicus, and Onchopristis numidus. This great similarity between the Cretaceous biota of Brazil and that of Africa results from the connection of the lands that formed the supercontinent Gondwana, which included most of the land masses of the modern southern hemisphere. This connection was interrupted by rifting and seafloor spreading 130 to 110 million years ago. After this, the transoceanic sets evolved separately, resulting in minor differences between taxa. Machado suggested that Cajual Island was still connected to the African continent during the Cenomanian. Similarly, Medeiros and colleagues noted that the presence of an island chain or another enduring land connection during this period could explain the faunal similarities. As a spinosaur, Oxalaia would have possessed large and robust forelimbs, relatively short hind limbs, elongated neural spines, vertical projections from the vertebrae, forming a crest or sail on its back, and tall neural spines on its caudal vertebrae that, similar to the tails of modern crocodilians, could have aided in swimming. Spinosaurs likely spent most of their time near or in the water, and primarily fed on aquatic animals, avoiding direct competition with other large predators while still being capable of feeding on terrestrial animals if necessary. This behavior is observed, for example, in juvenile iguanodontid bones found in the stomach cavity of a baryonyx fossil, and in an irritator tooth found in pterosaur remains. The conical and transversely oval teeth of Oxalaia, as well as its nostrils positioned further back on the skull than most theropods, likely to avoid water entering the nostrils while fishing, are characteristic features of spinosaurs. Both traits are useful adaptations for catching and feeding on fish. The expanded and interlocked front jaws and piercing teeth of spinosaurs functioned as an efficient fish trap, a feature also seen in the Indian gharial, the most piscivorous existing crocodile. Kellner compared the overall appearance of spinosaur skulls to that of alligators, and so we explore the fascinating connections between the flora and fauna of the Alcântara Formation and the distant lands of Africa during the Late Cretaceous. From the imposing spinosaurs with their aquatic adaptations to the intriguing similarities with the Kem beds of Morocco, the ancient history reveals an interconnected and vibrant world. The diversity of dinosaurs, fish, and other animals from this era offers us a window into a remote and exotic past, where continental boundaries were still fluid and life adapted in surprising ways. If you enjoyed diving into this chapter of prehistory and want to see more content about the world of dinosaurs and ancient eras, don't forget to subscribe to the channel and activate the notification bell so you don't miss any updates. Leave your like, share with friends, and comment below on what else you would like to discover. See you next time as we continue to explore the wonders of prehistoric life.